Here we have a quadrilateral ABCD. Two sides of this quadrilateral have the same length, BC and CD. Two angles, angle A and angle C, are 90-degree angles. We know the area of this quadrilateral, which is 64. We know one side, AD, which is 10. And we are asked to find the side AB. It is normally rather difficult to deal with quadrilaterals. It is much easier to deal with triangles, and we know more about triangles. So let's first split this quadrilateral into triangles. So we're going to draw a diagonal BD. We get two right triangles. The top triangle BCD, bottom triangle ABD. Now we know that side BC and side CD are the same length. That use some letter to denote its length. Well, let's call it Y. The triangle on the top, triangle BCD, has two legs equals to Y. By Pythagorean theorem, we can find the hypotenuse BD, which will be Y times square root of 2. And now we can look at the right triangle ABD and apply Pythagorean theorem to that triangle, and that gives us the relationship between X and Y. By itself, this relationship is not enough for us to find X because we don't know Y. But we can use this expression as one of the equations, and all we need to do is to find another equation that relates X and Y. And to do that, we'll use the fact that we haven't used yet, and that is the area of the quadrilateral. The area of this quadrilateral equals to the sum of the areas of these two triangles. And that gives us the second equation that relates Y and X. Now the first term represents the area of the top triangle. Area of the triangle is the base times height times 1/2. In the right triangle, things become simpler because both base and height could be taken as legs of the triangle. So we can say take BC is the leg, CD is the height. And therefore we get the formula like this. In a similar way, we can use, say, B as the height, AD is the leg. We're multiplying them together and dividing by 2. And that gives us the area of the bottom triangle. And the sum of them should be equal to 64. Now we have two equations, two unknowns, and we can solve the problem. So let's multiply the bottom equation by 2. And let's express y squared via x. And the next thing we're going to do, we're going to substitute this y squared value into the top equation. Now this is a quadratic equation with respect to x, so we can use the formula for the roots of a quadratic equation and find the solution. This equation will give us two solutions, but one solution will be positive, the other solution will be negative. In our case, we need to remember that x is the side of a quadrilateral, and therefore it has to be positive. But here what I want to do is I want to show you a different way to solve this equation without using that formula. First of all, notice that 256 is 16 squared. And if we use that fact and move this 20x to the left-hand side, that's what we're going to get. And the next thing, you may notice that the right-hand side looks familiar to you, and it will look familiar to you if you know this formula. So if you look at the right-hand side here, you will notice that the right-hand side right here is equals to x plus 10 squared. And now here what we need to do, we need to take square root and find that x plus 10 could be either plus 16 or minus 16. Since we're looking for a positive x, we find that we have to take a plus sign right here and get x equals to 6.